In my previous video, I've shown how we can use this graph to find the value of sine, cosine, and tangent of different angles. So in this video, we are going to learn how to find sine, cosine, and tangent of some angles. We are going to find them in their irrational form, in their surd form. And my video used to build on previous video. So if you haven't checked out my previous video, kindly check it out. So without further ado, let's start. Now, to find the sine of 45 degrees, what are we going to do? So we are going to make a right angle triangle that is isosceles using 45 degrees. And how do we arrive at that? How do we do that? Now we can use this graph by drawing a line that aligns with the 45 degree. Now we have the line, then we can form a right angle triangle using the line. Forming right angle triangle, you draw it vertically downward and you complete your right angle triangle. So I want us to observe something here before I draw another right angle isosceles triangle. Now let's count the number of the side. Now automatically this one becomes the hypotenuse because this is 90 degrees. Now let's find the value of this side, these two sides, using our graph. Now we have 2, 3, 4, 5, 6, 7, 8. This side is 8 units. Now let's find the value of this side. We have 1, 2, 3, 4, 5, 6, 7, 8. We can see that this is also 8 units. What I'm trying to do is I'm trying to show you that if you draw any line that align with any angle here and use it to form a right angle triangle, now you can still vary the length and you can use that to find the trigonometry ratio. That's what I've done for 45 degrees here. Now we can see that this one will still be 45 degrees, and don't forget that right angle isosceles triangle, we have two of its interior angles as 45 degrees, and because it is a right angle triangle, the third angle is 90 degrees. So that is what we've been able to see here, 8 units and 8 units. To form 45 degrees, what we just need to have is have a right angle isosceles triangle. So now we have right angle isosceles triangle here. So there is no doubt about it. This one will be 45 and this one will be 45 degrees. Yes. Now you can as well use a square for this. Using a square, you're going to divide the square into 2 equal parts using a diagonal, so you will get 45 degrees as well. Now this is what I'm going to do here. Since I know that the side will be the same, this side will be the same for isosceles triangle. So instead of using 1, 2, 3, 4, instead of using 4 units and 4 units, so I can convert it to, using scale, I can convert it to 1 unit, 1 unit. So I'm going to use 4:1 scale. So which means that this side here will be 1 unit and this side here will be 1 unit, since they are the same. If you don't use scale, we are still going to get the same thing. Now the next thing is to find the third side using Pythagoras theorem. This clean. Now using Pythagoras theorem, the third side will be what? Let's call this third side on no side x. So we have s squared is equals to 1 squared plus 1 squared. So we have s squared is equals to 1 plus 1. Then we have s squared is equals to 2 here. And we can have our x is equals to square root of 2. Here we go. So we can have this side can be what? Square root of 2 unit. That is root 2 unit. Now we can start finding the trigonometric ratio of 45 degrees. To start with, so we are going to start with sine. So which means sine 45 using this will be what? 1 opposite over hypotenuse. Your opposite is 1. If you choose this 45, your opposite will be 1. If you choose this 45, your opposite will be 1. So we have 1 over root 2. This is hypotenuse. So that is 1 over root 2. Then using irrational form and rationalizing the denominator, this is coming from surd, from a rational number from surd. Now rationalizing this, let me quickly teach you how to do that. Now this is coming from the fact that if you have a fraction and you multiply another fraction with that number, and that fraction, the denominator is still the same as the numerator, get the same answer. What did I mean? If you have 1 over root 2, you multiply it by 6 over 6, is still the same thing as 1 over root 2. You multiply 1 over root 2 by a over a, you still get the same thing as 1 over 2, because at the end of the day, a can cancel a. So which means that if you have any fraction, multiplying it by another fraction that the denominator is still the same as the numerator, what you are just doing is you are still getting the same number. So which means that 1 over root 2, since I want to rationalize this denominator, I don't want to have roots as the denominator, so I can multiply this by root 2 over root 2. So it's still the same thing as leaving it as 1 over root 2. So I have 1 over root 2 multiplied by root 2 over root 2. This root 2 can cancel this root 2, so I'm still left with 1 over root 2. So instead of doing that, I can go ahead and multiply the numerator by each other and the denominator by each other. So I'm going to have 1 multiplied by root 2 here, so I have root 2. Then root 2 multiplied by root 2, so I'm going to have root 4. And what is the value of root 4? That is 2. So this is the reason why sine 45 is still the same thing as root 2 over 2, and is still what? 1 over root 2. You can confirm that by using your calculator. We'll still get the same thing, but most time in mathematics they used to rationalize the denominator. That is why we have root 2 over 2. That is sine 45. If you do the same thing for cos 45, what are we going to have? Since opposite and adjacent here, they are the same, so we are still going to have the same thing, 1 over root 2. And if you rationalize it, so you still have root 2 over 2. That is sine 45 and cosine 45. And the next is tan 45. Now tan 45 is still sine 45 divided by cos 45, or you use opposite divided by adjacent. You can do it the same way. So what is the opposite? 1. What is adjacent? 1. 1 divided by 1, you still get 1. So we have tan 45 degree is 1 over 1, which is 1. Or 1 over root 2 divided by 1 over root 2, that is 1. Root 2 over 2 divided by root 2 over 2, that is 1. That is tan 45. We can see how we use this. You get the value of sine 45, cos 45, and tan 45. Let's go ahead and do the same thing for 60 degree and 30 degree. We have seen how important right angle triangle is to Pythagoras theorem, trigonometry ratio as well. Now we are using equilateral triangle. So let's have our equilateral triangle. Don't forget, equilateral triangle is having all its sides as the same. So all its interior angles is also the same, and exterior angles, each interior angle is 60 degrees. This equilateral triangle is going to be 2 units. You can use 1 unit, you can use 3 units, you can use any unit of your choice, but I will advise you to use 2 units. Now let's use 2 units equilateral triangle. The next thing we want to do is we want to convert this triangle to right angle triangle, and how to do that is, so we are going to draw a perpendicular line, perpendicular bisector of this angle here. So we draw it to this point, to this line, so which means that this equilateral triangle has been divided into 2 equal parts, which is right angle triangle. Now we have right angle triangle here. Now we have this angle, which is 60 degree, has been divided into 2 equal parts, which is 30 degree and 30 degree here. So we can now use either of these triangle here to find sine and cosine of 30, 60 degrees. So let's pick one. Now, since we have divided these 2 units into 2 equal parts, so it means that from here to here will be 1 unit, and from here to here will also be 1 unit. And before bringing 1/2, so we still need to find this line, the value of this line with respect to what we have. Pythagoras theorem to find the value of this line here, this length. Now to find it using Pythagoras theorem, so we have x squared is equals to 2 squared, which is your hypotenuse, minus this is the adjacent here, which is 1 square. So we have 2 square minus 1 square. 2 square is 4 and 1 square is 1. So we have s square is equals to 4 minus 1, and that is s square is equals to 3, and we have x will be square root of 3. Now, which means that this side, so let's put it there. So we have root 3 units here. So now let's bring out our triangle and let's bring this side out. Now this is it. So we have 30° here, we have 60° here, and then we have 90° here. We also have root 3 units here, and we have 2 units here this side, and we also have 1 unit here. So let's go ahead and find the trig ratio of 30 and 40, 30 and 60. Now for 30° sine, 30° will be opposite over hypotenuse. What is the opposite here? Opposite to this 30° is 1 unit divided by what is hypotenuse? 2. So we have 1 over 2. Sine 60° will be opposite over hypotenuse. What is the opposite? If you are using 60°, we have root 3. And what is the hypotenuse? We have 2. The same thing with cos 30°. Cos 30°, that's adjacent over hypotenuse. What is adjacent side of 30°? We have root 2. What is the hypotenuse? We have 2 root. So we have root 3. What is the hypotenuse? We have 2. So we have cos 30° is root 3 over 2. What is cos 60°? That is adjacent over hypotenuse. What is the adjacent side of 60° here? We have 1 unit over hypotenuse is 2. We have 1 over 2. Now for tan 30°, you can choose sine 30 divided by cos 30, or you use your opposite divided by adjacent. So let's use opposite divided by adjacent here. Now the opposite to 30° here is 1, and the adjacent is root 3. So we have 1 over root 3. You can rationalize this. How do you rationalize this? You rationalize this by multiplying this by root 3 over root 3, and you are going to get root 3 over 3 as shown. That is tan 30°. The same thing with tan 60°. Tan 60° is what? Tan 60° is opposite over adjacent. What's the opposite? That is root 3. What is adjacent? 1. So tan 60° is what? Root 3 over 1. And what is root 3 over 1? That is root 3. Why? Tan 30° is 1 over root 3. Tan 60° is root 3. Tan 60° can as well be 3 over root 3. That is the beautiful thing about mathematics. Here is a quick recap of what we have learned so far. We were able to get the surd form of sine 45, cos 45, and tan 45 using an isosceles triangle. Thereafter, we are able to get the surd form of tan 60, tan 30°, cos 60, cos 30°, sine 60, and sine 30° using equilateral triangle. These values are important for us. We must know this value when we start solving question under trigonometry. So we are still going to solve a lot of questions. Mind you, these are just the beginning, the basics of trigonometry. So we will be needing all these to solve a lot of questions, even in physics as well. So make sure you know all these things. Now, if you haven't subscribed to my channel, kindly subscribe to my channel, like my video, share my video, comment in the comment section your view about this video. If you haven't checked out my channel, so I have various playlists for learning, so self-learning playlist. So you can check out my playlist on matrix, Euclidean geometry, circle geometry, coordinate geometry, trigonometry, mechanics. So make sure you check them out and start learning. Whenever you pick a playlist, make sure you start from the first video, because most of the struggle, most of your challenges have been addressed in the first 3 video in any playlist you are choosing. So don't just watch the video randomly. Make sure you watch them and then you start from the beginning, from the basics. And also know that my video used to build on previous knowledge. So for instance, my next video is going to build on this current video. So make sure you follow my video so that you will not get lost. So alright, thank you for watching this video. Still blessed. See you in the next video. Bye for now.